What specific problem does the large reasoning models, LRMs, aim to solve in the context of machine translation, MT, as described in your paper?
Large reasoning models, LRMs, aim to address several critical challenges in machine translation, MT, by enhancing the translation process through reasoning capabilities. Specifically, LRMs focus on improving contextual coherence, cultural intentionality, and self-reflection during translation. They resolve ambiguities and maintain discourse structure across complex contexts, adapt translations to infer speaker intent and sociolinguistic norms, and iteratively refine translations to correct errors, particularly in noisy or ambiguous scenarios. Additionally, LRMs tackle issues like stylized and document-level translation, where maintaining consistency and coherence across lengthy texts has historically been problematic for traditional MT systems. By reframing translation as a dynamic reasoning task, LRMs significantly advance the capabilities of MT systems beyond mere text conversion.
How does the proposed large reasoning model work? Illustrate its methodology step by step, including any key components or techniques involved.
The proposed large reasoning model, LRM, operates by integrating reasoning capabilities into the translation process, fundamentally transforming how translation tasks are approached. First, LRMs utilize chain-of-thought, COT reasoning to analyze the context of the original text, allowing them to resolve ambiguities and maintain coherence across sentences and paragraphs. This step involves understanding the stylistic features and cultural nuances of the source text, which informs the translation output. Second, LRMs employ self-reflection during the translation process, enabling them to identify and correct errors dynamically, particularly in cases of noisy or ambiguous input. Lastly, LRMs can engage in auto-pivot translation, where they internally reason through a high-resource language to facilitate translations between low-resource languages, enhancing their effectiveness, while also raising questions about potential biases and inaccuracies in the final output. This multifaceted approach positions LRMs as advanced cognitive agents capable of deeper contextual understanding in translation tasks.
Can you come up with a simple yet illustrative example that showcases the inner workings of the large reasoning model, particularly focusing on its self-reflection capabilities during translation?
An illustrative example of the large reasoning model's LRM self-reflection capabilities can be seen when translating the ambiguous Chinese sentence, Bu huo de shi lai ren. Initially, the LRM interprets this as, the hunter is the one who hunts. However, through its self-reflection process, the model revisits its reasoning and considers an alternative interpretation. The one who captures is the hunter. This iterative evaluation allows the LRM to refine its translation dynamically, demonstrating its ability to correct errors and enhance accuracy, especially in scenarios with ambiguous or noisy input. This capability is particularly valuable in real-world applications where input quality can vary significantly, showcasing how LRMs can improve translation outcomes through self-assessment and adjustment.
What are the theoretical or practical benefits of using LRMs over traditional neural machine translation, NMT, and large language models, LLMs?
Theoretical and practical benefits of using large reasoning models, LRMs, over traditional neural machine translation, NMT, and large language models, LLMs, include enhanced contextual coherence, cultural intentionality, and self-reflection capabilities. LRMs leverage chain-of-thought reasoning to resolve ambiguities and maintain discourse structure across complex contexts, which traditional NMT systems struggle with, particularly in long documents. Additionally, LRMs can adapt translations by inferring speaker intent and sociolinguistic norms, addressing challenges that LLMs face in zero-shot scenarios. Their self-reflection ability allows LRMs to dynamically correct errors during inference, improving robustness in noisy or ambiguous inputs. Overall, LRMs redefine translation as a reasoning-driven task, enabling deeper cross-cultural understanding and communication, which is a significant advancement over both NMT and LLMs.
How did you validate the performance of the LRMs in your experiments? What datasets, metrics, and benchmarks were used to demonstrate their effectiveness?
In our experiments, we validated the performance of large reasoning models, LRMs, by comparing them with various other models in translating Chinese to English sentences, specifically focusing on common sense understanding. We utilized automatic evaluation metrics such as BLEURT and COMET to assess the translation quality. Although the results did not show significant differences in scores between the models, qualitative analysis revealed that LRMs could generate more diverse translations that, while potentially lower in score due to differing wording from reference translations, were contextually accurate. This discrepancy highlighted the need for new scoring metrics that can better account for the quality of translations produced by reasoning models, which may not always align with reference translations. Overall, our approach combined both quantitative metrics and qualitative assessments to demonstrate the effectiveness of LRMs in translation tasks.
What significant results were achieved in your experiments with LRMs compared to other models? And what do these results imply about their performance and potential applications?
In our experiments comparing various models, including those with and without reasoning capabilities, we found that while automatic evaluation metrics like BLEURT and COMET did not show significant differences in performance, qualitative analysis revealed notable advantages of LRMs. For instance, DeepSeek R1 produced a translation that, despite receiving a lower COMET score, was contextually more accurate than its counterpart, DeepSeek V3, which received a higher score due to its closer alignment with a reference translation. This discrepancy suggests that LRMs can generate more diverse and contextually appropriate translations, which may not always align with reference outputs, but demonstrate a deeper understanding of the source material. The results imply that LRMs have the potential to excel in applications requiring nuanced translations, such as low-resource language translation and interactive translation, where understanding context and intent is crucial. Overall, these findings highlight the need for new evaluation metrics that better capture the strengths of reasoning models in translation tasks.